When you see this, you might ask, what is this? Well, my friend, this is a packed column, and today I will be guiding you through the gas stripping in a packed column. Now, the objective for a gas stripping pack tower is to strip a contaminant from a liquid with a gas. Therefore, we need to analyze mass transfer in such liquid-gas operation. Some key design variables include the height of the pack tower and diameter. Empirical correlation can be used to estimate the column dimensions. The column dimensions are factors that can change the gas velocity, which can contribute to the flooding. We need to comprehend the relationship between the flow rates and the flooding velocity. This is the general schematic of a packed column. The liquid, in this case the contaminated water, is coming in at the top of the column, while a gas inlet is from the bottom. The packings in the column can provide a large area for mass transfer, and at the same time promotes a uniform liquid and vapor flow across the cross-section of the column. There are different types of packing: packings with regular geometry, such as rings, grids, and random packing, such as saddles. Packed columns can be used in vacuum distillation, separation, filtration, and purification processes. It has been used in industries since the mid-19th century. It is used in industries such as pharmaceutical, coal mine, petroleum, and other chemical processes. This is a packed column from a pharmaceutical chemical container factory company in China. This vessel can remove acid and toxic gases through absorption and neutralization. Safety is of the utmost importance. On top of no horseplay around in the lab, the following guidelines need to be pointed out. Personal protective equipment needs to be worn at all times in the lab. This includes safety goggles, lab coat and long sleeves, gloves, long pants, and closed-toed shoes. It needs to be ensured that all piping and valves are secure with no leaks. Also make sure the gas outlet is in the fume hood. By doing so, it will prevent toxic ammonia vapor from distributing throughout the lab. It is also worth noting that there is an ammonia sensor in the fume hood that can measure the concentration of ammonia. Sodium hydroxide is extremely painful when it comes into contact with the skin and eyes, as it will lead to severe burns and blistering. Be sure to wear gloves. The inhalation of ammonia is very toxic and can cause death. It is also corrosive to the skin and eyes. Let's understand this process by tracing the liquid process. The liquid is fed from this tank. See there? There is a valve. This is where we can take the liquid inlet samples. As the liquid gets pumped up, it is fed through this pipe. The liquid is then controlled by the volumetric flow meter. Then it leads through a pipe up to the top. As the gas strips the ammonia from the liquid, it exits from the bottom and is recycled back into the tank. There is a purge stream within the recycle stream. This is where the samples are collected for the exit liquid stream. When it comes to the gas stream, we are using air to strip the ammonia. Therefore, air is going through the compressor, then set up the gas volumetric flow meter. It is then guided to be sent through the bottom of the packed column. As it travels up through the tower, the gas outlet is led towards the fume hood. In order to determine the mass transfer rate of the ammonia between the liquid and the gas stream, the column needs to be in steady state. After setting both the volumetric flows for both the liquid and the gas, wait 20 minutes for steady state to be reached. Recall there may be backup of the liquids, so be sure to drain the exiting liquid stream. After it has been drained, collect two 50 ml samples from both the inlet and the outlet of the liquid stream. Be sure to recycle all the liquid that is drained. Once the liquid is collected, use parafilm to cover both samples to prevent any reaction between the air and the solution. The anhydrous ammonia ion selectivity probe is used to calculate the moles within the liquid samples. In order to analyze the solution, sodium hydroxide must be added to the samples before placing the probe in the solution, as the probe itself is only sensitive to anhydrous ammonia but not to ammonium. Adding sodium hydroxide causes the solution to have a high concentration of OH negative ions and drives the equilibrium reaction. Remember the flooding that was mentioned in the beginning? Well, flooding is when the packed column is filled or backed up with liquid. It is caused by excess vapor flow, where the vapor causes the liquid to be pushed up the column. Also, due to the elevation of the column and the exit stream, there may be potential for liquid backup. To prevent this issue, use the purge stream to collect the backed up liquid and pour it into the tank. Doing so will keep the liquid constant in the system. To test the flooding condition, keep the liquid flow at constant, then increase the vapor flow until the column is observed to be flooding. A sign would be bubbling at the bottom of the column. At this point, flooding velocity is reached. Now that we've reached the end of the packed column tutorial, we hope you learned a lot. If you did, please drop a like. Don't forget to comment and subscribe. We'll catch you on the next time. Bye.